Good evening, student. Today my topic is Gaussian surface. So what do you mean by Gaussian surface? Why use that type of Gaussian surface? So Gaussian surface is an imaginary surface in three-dimensional, so that we have to calculate electric flux. Okay, that means it is a hypothetical imaginary surface, so that we have to calculate electric flux due to that surface. It may be spherical or cylindrical. For example, if you consider a point charge, due to point charge, the electric field line goes outward from that point charge like that. So we assume a Gaussian surface. That Gaussian surface behaves as an spherical. Okay. Due to spherical surface, the distance between the center of sphere and the surface having equidistance in all region. So electric field intensity remains constant in every direction. Clear? Electric field intensity remains constant in every direction. So we assume a spherical surface. If you consider a line charge, here this one is a line charge. That means the number of charges are distributed uniformly on that line. Due to line charge, we have to calculate the flux, so that we represent a curve. That curve behaves as a cylindrical. That means due to plus charge, the electric field going in that direction, again in that direction, and the distance between them in both of the region remains same or equidistance from that line. So it represents like that, and that length which is equal to that length, and also it has another surface. So due to line charge, a surface which is drawn, so that we have to calculate flux in three direction. In first direction, that area, second is along that area, third one is in curved area. This is the curved, because this is a cylinder. If you represent, this is the cylinder, and it is the one surface, and second one is the another surface, third one is that is another surface. Here in that case, the electric field intensity moving in that direction, and the orientation of area of that curved surface, of that curved cylindrical surface, which is drawn outward like that, outward. That means electric field intensity and the area vector both are in what? Same direction. But in second surface, the area vector moving in that direction and the electric field intensity moving perpendicular to that area vector. Similarly, opposite case, the ds vector is in that direction and the electric field is also in that direction. So net electric flux phi can be represented as, we know, the surface integral of E vector dot ds1 vector for first surface, s1 surface, this is the second surface, and this one is the third surface, s3. So E1 dot ds1 vector plus E vector dot ds2 vector plus E vector dot ds3 vector. So integration. So that means, therefore, we have to calculate net flux due to a line charge by using a surface. That surface behaves as an Gaussian surface. Clear? If you consider a plane sheet, so this is the plane sheet, and that plane sheet consists of number of charges. They are uniformly distributed. Now I have to calculate electric flux due to a plane sheet. So that we have assumed a small region on that surface, and if you represent a cylinder here, so the Gaussian surface behaves as a cylindrical surface due to calculation of flux from the plane sheet. So for above consideration, we assume a Gaussian surface by calculating electric flux. Thank you.